all classes so far we have covered, and find that we have till date one lacuna, that no general class on AI, that how it is working actually, what is the behind the screen activities happening. So that part is
So
slightly
I would
missing.
just like to interrupt.
Yeah, please.
So we would like your okay, it's being recorded, na? Okay, because we would need that. So for that, okay, I just missed out that. Sorry, please continue.
Yeah. Recording started. You will be getting the clip. Okay. So
Yeah, okay,
first,
thank you.
okay. So first, we will be discussing the some of the behind the screen activities, a little bit of AI literacy, what is happening in the back end. Not only mere tools, because you see, you are all intelligent people, assembled here. So introducing you people with a mere set of passive tools which you can access through your browser is not the goal of this workshop. The goal is that a kind of AI literacy, so that we can deploy some of the tools, because I'm quite sure that you have tried many tools and you have already got a limitation. So most of these tools are available in the free tier. The moment you want to go to the premium tier, you need to pay a lot. So that is basically the story of the present AI tools. The premium subscription requires money, and the free tier involves many limitations. For example, the number of tokens limitation, then number of queries are limited, and many such things. Most of the productive things you will be finding not available in the free tier tool. So how can we deploy the full-fledged AI? And therefore, you see, that means freedom, and freedom always cost something. And here, the cost of freedom is the learning curve. You need to learn a little bit, and a lot of open source tools are available. So every bit and pieces of this particular deliberation, what I'm going to present before you, are based on these open source tools and open standards, so you do not have to pay anything to anybody. And don't think that I am using here Linux operating system, that means all tools are limited to that operating system. It's not like that. In your Windows, if you have a Python environment, and nowadays there are loads of tutorial available how to install Python programming environment. It takes only 2 to 3 minutes in your Windows machine. Your machine must have at least 8 GB RAM. The preferable is 16 GB, and anywhere between 20 GB to 100 GB of free space you need, and then you can do the magic by your own. And there are a lot of productivity you can increase, which are not available in the free tier. You have already explored different kind of tools. So that is my motto here, that how we can go one step further, not only utilizing those are all good tools that can increase your productivity. I have no objection with those tools, but we need to learn a bit to move beyond that free tier tools. So that is the motto of this particular class. So let me share my slide first, and there will be a lot of hands-on demonstration process in between, alongside the slide presentation. So I am taking this slideshow in window mode, so that I can have a control of this my slide. Okay, so it is now clear to all of you, the audio and video both. You can see the slide. Can you see the slide? The
No, no,
movement.
no, 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 no. Till now it's not visible. I don't know if others can see. I cannot see. Someone else, please confirm.
Not visible.
Okay, okay, okay. So let me try again. What you were seeing, a black screen only?
Yes, sir. Black screen only.
share started screen sharing, it's showing, sir.
Mhm. Okay.
No, till now it's not visible, I think.
That means you are getting black screen. That is
Yes,
Yes,
yes.
sir. Till now it's not visible.
okay. That means it's a network issue. Let me check. Let me check. Maybe I
In
need to
any
change.
case, even if you're unable to share the PPTs, the PPT should reach us because we have been waiting for your lecture so eagerly.
Oh, no, sure, sure. After this one, I will be sending the PPT and video recording will be available. No issue. These are all open access. No issue.
Yeah,
So let
thank
me give me 2 seconds so that I can change my network and okay recheck the sharing because I have to demonstrate a lot. So sharing is the must. Fine.
So now it is visible, sir.
Okay, fine. So I think it is visible now.
Not, sir. Yes, yes, sir. Now it's visible.
Yeah, yeah,
Okay,
yes,
thank you.
it's visible.
fine. Okay, so you know that you have already an idea that this AI, machine learning, and AI, which basically we pronounce synonymously, although they are not synonymous, the scopes are different. But it's a interdisciplinary domain, data science, then different kind of neural network model, deep learning, all are fusing together and giving us or producing a different kind of domain for us which is exclusive in nature. So it's like space science or space biology, for example. It takes space science actually takes input from different disciplines. It's a agglomeration of subject. So similarly, artificial intelligence and machine learning takes theoretical base from mathematics, physics, then principles of data science, because finally it is data-driven artificial intelligence. So it's a interdisciplinary domain. Input is coming from different disciplines. Now, you are wondering of the one thing that why people all on a sudden started talking AI/ML in the post 2023 scenario. Uh, and sometimes I think it's a bamboo sapling effect. And science, it is very common. In science, it is very common that one particular discipline is almost sleeping for a long period. Then all on a sudden, it came out in the public and grown like anything. So this happens in the nature also. Those who are from the countryside like me, this they know this particular phenomenon. Bamboo sapling takes almost 5 years to come out of the soil. Then all on a sudden, within 5 weeks, it can grow up to 90 feet. So this kind of phenomenon when happens with a subject, we call that bamboo sapling effect, and that perfectly, AI/ML domain is fitting with that, because my dear friend, it started long back. I'll be coming that when it started. It started in 1936 with a paper written by the famous British mathematician Alan Turing, and he developed a machine called Turing machine. Later on, that actually converted into Enigma, and that machine single-handedly changed the course and future of the World War II. The One of the major reasons of the defeat of Germans was this machine Enigma developed by Alan Turing, and there is a beautiful film based on this particular event or success of Alan Turing, that is called Enigma. You must see that. Okay, so we'll be coming to that. Who is Alan Turing and what is his contribution? But before that, although Tonima is here, she is an authority here from biological domain. I don't belong to biological science. So this is the evolutionary biology facts and our journey as Homo sapiens for the last million and million of years. So first Homo species, that is Homo habilis, appeared almost 2.5 million years back. And within these 2.5 billion years, very interestingly, Tonima may throw some light on it, why this has happened, because I found no answer of it. As a species, we are basically animal. We belong to the animal kingdom, and rational animal, we can call us. And why we have not tried to develop our other skills like running, more fast running. Then we never tried to build our muscles. We never utilized our nails and teeth. We always given emphasis on the development of brain. And you see here over the generations after generations in the genus Homo and species sapiens, Homo sapiens, how our skull size is growing. If you compare the skull size from the earlier species to the latter species, it almost grown to 4 to 5 times. Why we have given all of our evolutionary effort only developing the brain, and that differentiated us from the rest of the members of the animal kingdom. We never tried anything to fit into that particular competitive world except the brain. And brain is a very costly device. When you are doing nothing, your BMR is almost zero or very low. When you are lying on bed and in the deep sleep, then also brain draws 25% of your body energy when you are doing nothing, and brain never sleeps. So that's a biological question. Nobody knows the right answer, that why a single species in this evolutionary biological cycle given all emphasis to develop brain, although other species over the generation develop different other earthly features and different kind of flexibilities. We never did that. Because, my dear friend, our skull size has increased manyfold. If you compare the gray matter of chimpanzee to the latest, our present generation, it's almost 4 times. So chimpanzee, the closest relative DNA wise to the human species, chimpanzee around 500 cc, and the modern Homo sapiens holds a brain size of 2000 cubic centimeter. Amazing. So over the 2 million years of time, this spans of time, we never attempted to develop other bodily features, only developed our brain. And what brain returned us? Almost past 2 million years, nothing. And you will be wondering that why I am venturing into a domain what I simply do not know. Because, my dear friend, the technology we are talking is a poor imitation of human brain. There lies the difference. All other technologies in the world, what you have developed, what human race has developed, are either extension of your hand, leg, eyes, noses. That is the five sense organ. When you are looking at a microscope, are not you extending your eyes, the power of your eyes? When you are looking your telescope, that is also an extension of eyes. When you are using any speeding vehicle, train, a different kind of mass transportation, your own vehicle, extension of legs. You are using lot of big cranes and other thing, extension of hand. So most of the technologies you will be seeing around, including your ceiling fan, table fan, all are either extension of your five sense organ. But this technology, the computing technology, right from the beginning, attempts only to imitate brain, and there lies the difference. So how far we can imitate our brain, how far we can replicate, the model names also, you see how closely it is related to the brain system, like neural network, deep learning. So we have an interaction. This technology has an interaction with the brain. So I read a little bit about this, and this is basically the feature. Our gray matter, our brain matter is increasing manifold. Still, I think 10 to 15% we know how brain works. 80 to 85% we simply do not know yet. And what brain returned us in the past 2 million years? Almost nothing. Can you believe it? You are investing all of your evolutionary capital in a single device, brain, and brain is returning you nothing. Why I'm saying so? So right from this 2.4 million to 1.5 million, 5 million year, in the BC or before Christ, time goes back actually. So 2.4 million to 1.5 million, we developed old one tools, and this kind of blunt tools we utilize to break the bones. And why we needed to break the bones? Because we were not capable to hunt bigger animals than us. So we were waiting that one big animal will kill another big animal. They will take all the flesh and mass, and the bones will remain. We'll break the bones and we'll take the bone marrow as a nutritious food. So that was the purpose of the tool. You may be amazed, but you see how insignificant we were in the food chain pyramid. We were almost at the bottom, almost at the bottom. So and we were very easy, to hunt. Anyone can hunt. We cannot run. Our different bodily capabilities were limited. We cannot fight back. So we were easy target for other bigger animals, and that's why we lived in the past almost 1 million years, 2.4 to 1.5. Then you see these are called Apulian tool, that 1.5 million to 0.2 million years. And see how our tools are changing. Now these are double-edged, slightly, more sharper. So we adapted our brain power only to convert a rock as a tool to break the bone, a tool to kill the smaller kind of animals. That's what the brain given us for the in the beginning almost 1 million years. And the return is very low actually, but still we never stopped. We invested more energy on brain. In fact, we deprived all our other organs in developing the brain only. Nobody knows the reason why this is. Almost it goes against the principle of evolutionary biology, but still human race as a single species done it. Nobody knows. Can Tony can throw some light in the latter part of this? And the process continues. See this 1.5 million to this one, and you see this is the later technology, rock based technology, and how these tools are taking different kind of shapes. These are called Paleolithic tools. So 40,000 years ago to 12,000 years ago. So almost 12,000 years ago, this we were capable up to this only, nothing more than that. But the bamboo sapling effect took place again. If you take a miniature form of the entire human civilization for the last 2.5 million years, you can relate it to your development of AI technology, and all on a sudden the proliferation of that kind of technology. So our Homo habilis journey age, or our journey, started 2 million years ago almost. Homo sapiens age began only 1 million year ago, and then tribal is started only 40,000 years ago, like different kind of tribal kingdom, sect and other thing. Race actually came from this tribal age. Then agriculture age, we are now little bit knowledgeable. We know how to use food, how to use fire in making food, how to cultivate things. So from the hunter gatherer, up to this point of time, we were just mere hunter gatherer, and now in the agriculture age, we got some time, because you see, up to this point of time, we never knew how to utilize fire in food preparation. So we took raw meat. Digestion of raw meat almost takes 18 hours. So after taking the raw meat, we slept for 18 hours. Then we again awake with hungry, and again go for hunting. So we have not given brain enough scope to develop different other faculties, human faculties like music, arts, literature. We never given brain time. There is a famous Bengali proverb, Onna Chinta Chamatkara. You are not giving your brain enough time to think beyond food. So brain has done nothing. But in agricultural age, when we got some free time, we learned how to use fire in food preparation. The moment we started boiled the raw meat into a more digestible food. So the digestion period came down from 18 hours to 3 hours only. So all on a sudden, we started getting almost 12 hours extra. So in that 12-hour extra time, made different kind of miracles. All the faculties for which human, race is known for, thinking, a tool making, then different kind of, as I said, a finer, side of the life, that is music, literature, etc. All came during this agricultural age. Agricultural age led us to empire age almost 2.5 thousand year ago. And you see how when you are going for a miniature kind of thing, it seems that almost yesterday. So 2.5 thousand year ago, a lot of civilization, Sumerian civilization, Maya civilization, Inca civilization, Egyptian civilization, Roman Empire, all actually came during this period of time. Then can you believe it? The age of science, that's thinking process of the science. Science is based on only three facets. Experiment, observe, infer. So experimentation, observation, and inference. So on the basis of that, you draw your inference and you apply, try to make some general rules, apply that theory. So that process started in the hand of Francis Bacon, Roger Harris, only almost 400 years ago, to be exact 380 years ago, 1500, then within 200 years after this science age, we reach to industrial revolution, industrial age or industrial society, and that is only 200 years ago almost, 1770 started. And with the advent of personal computer, we entered into information age. And you see 1950, when IBM first gave its IBM clone PC, a very low cost PC. Particularly in 70s, the low cost PC came, but the architecture and other thing, already it was there in 1950. Transistor developed, device, discovered and created, invented in 1950, for which that person got more on Nobel in 1998 after almost 48 years. So information is started 70 years back, and presently we are in the symbiotic age. You all know symbiosis. So why it is called symbiotic age? Because there is a man-machine symbiosis. Can you imagine a single minute in your life without the help of a machine? Right from the morning, your dependency on your this submersible pump started. It brings water to your overhead tank, then it goes to a different kind of lifeline of the your home. So right from the morning, all of our choruses, all of our activities depending on machines. We can't think a single moment in our life without a machine. There is I can give you one very interesting fact of this symbiosis, and human race is benefited from this symbiosis. You see, your relationship with your mobile phone, you just imagine for a single second. And a recent survey came with a very surprising result. An average human being, those who are having smartphone access, opens up his or her phone 80 times in a day. And a day means 16 hours. When you are sleeping for 8 hours, it is not calculated. In within the 16 hours, you are opening your phone 80 times. I don't have any objection because you are connected through that one. But the real disturbing fact is that when they inquire that why they are opening their phones so frequently, half of the time they simply do not know why they are opening their phones. Can you believe it? A very surprising result. I am opening my phone on an average 80 times or more in a day, and half of the time I simply do not know why I am opening my phone. And that's, my dear, called mental dependency, symbiosis, your relationship with your devices. So you need to think of it seriously, that how this symbiosis is going to help us, how it is going to happen, because everything has a good side and bad side. And they're predicting that by 2050, this symbiosis will be over and we will be entering into the complete automation age. You can object, sir, we are already in the automation age. We have beautiful banking automation, we have library automation, we have industrial automation, what not? But that is not complete automation. When you are thinking of banking automation, process automation, industrial automation, library automation, every second human intervention is needed. Every second. Suppose you are forwarding some fund to your friend through your mobile banking app. How many times you need to give OTP, then your MPIN, then again reconfirm it. So every second it requires human intervention. It's not complete automation. Complete automation is that you are giving a command, maybe through your speech or text, that I want to send this amount of money to that person. That's all. That will be the complete automation age will be started in 2050. But interestingly, most of the research is going presently on tech singularity. You all know the Big Bang theory by Hawkins, uh, the singular universe, and then all on a sudden it created. So how we are moving, that particular phenomenon is tech singularity. What it is, up to this 2 million years and up to 2060, we have not and we won't be able to build a machine which is smarter than a human being. We prepare them, we control them, we program them. But in 2060, we will be able to produce a machine which will be smarter than a human being. They can program by themselves. They can determine the objective. They can take independent decisions. So AI is basically in its infancy. It's basically giving a crawling on the a floor. Nothing more than that. What AI you are seeing and wondering every day, that is basically infancy. In the matured level, that can program by itself. It may appear as a Hollywood movie, but it's not. So that kind of smart machine, when human race will develop, that particular point will be called tech singularity. Because then onwards, my dear friend, no one is ready to guess, no one is ready to predict the future of human race. What will happen to us? Will we be extinct? Nobody knows. So it's AI ML is not only a mere set of tools. A lot of more things are associated with this one. And the planetary cost of AI, another beautiful fact brought to us by a lady called Kate Crawford. Her book you can read, The Planetary Cost of AI. So GPT 4.0 model, the planetary cost wise, if you calculate the carbon footprint of that particular building process, it is equivalent to 90 times you are going and coming back from moon to earth. 19 times the different kind of biofuels you will be uh, using. The carbon footprint generated by that process is equivalent to the energy we consume to develop the GPT-4.0 model, what is the latest large language model of OpenAI. So is it a sustainable AI? Is it the right technology, or we need to something different? I don't know. Simply, these are big questions, but this is in a nutshell, a basic, introduction to AI ML. What this particular course was missing. Uh, so I started with this, but don't worry. A lot of tools will be covering during this point of time. So let us jump into our, or rather, make a quantum jump into our talk of today, and let us start in a lighter note. So that was a brief introduction to AI/ML. Some questions I raised so that you can think, a food for thought kind of thing. You all are intelligent people here. Two facets are very important. Is it a sustainable technology with that kind of planetary cost involved? So you please read that book, The Planetary Cost of AI. It's available in open access. And another thing is that this one, the tech singularity. What will happen when human race will be able to produce a machine smarter than human? But anyway, those are some kind of philosophical question. So we are now coming back to our target area, that is AI/ML tools for scholarly communication, and let me start in a lighter note. And because you see, all on a sudden, people like us interested in AI/ML, the main reason is the large language model, or what we call more specifically GPT model. Chat GPT as a product came from OpenAI. Google came with BART, Gemini. The model is BART, product is Gemini. There are a lot of other, races. Facebook came with the Llama model. So lots of other initiatives are going on presently. So what happened up to 2019? It was before Christ. BC stands for. And in 2021, you all know COVID happened. So BC all on a sudden change its stand, and now before COVID. And in 2022 November, ChatGPT first appeared in the public domain, and we were wondering what is happening. I don't understand how a machine can write flawless English, paragraph after paragraph, on virtually on any topic. We all started wondering. First time we realized the power of artificial intelligence, although it is still in its infancy age. So now it is everything, before ChatGPT and after ChatGPT, life is not the same. So with this lighter note, the sad reality is that we are hooked with different kind of infotainment devices. Meanwhile, machines are learning. And as I said, that the seed of this development actually planted way back in 1936 by a uh, beautiful, mind called Alan Turing. And his biography is worth reading. His contribution in the World War II, his personal life, the crisis, identity crisis, all are, really, really thought provoking. So Alan Turing developed and wrote a paper and developed a machine. I already told you, but the father of the modern AI is considered as John McCarthy at MIT. Way back in 1958, he developed a programming called a language called LISP, and then followed by another beautiful programming language for artificial intelligence called Prolog, and finally in 2018 development of ChatGPT. And still date we remember the legacy of Alan Turing. Many of you basically, I am definite that all of you actually got this symbol. Yes or no? You know this? Have you seen this? This symbol?
Yes, sir.
We call it captcha, is not it? Ironically, a machine is testing whether I am a human being or not. A very ironic thing. If you think in the deeper, mind, you will be astonishing that a machine is testing that whether I am a human being or not. What an irony. But anyway, we call it CAPTCHA, and you see here it's an abbreviation. The T in CAPTCHA stands for Turing. So the full form is completely automated public Turing test to tell computers and humans apart. So Turing given a set of tests that whether an AI is really AI, how to test it. That is called Turing test, and every AI needs to pass that particular test. So this Turing, we still remember the legacy of Turing, and we all consider him as a father of AI, along with the John McCarthy. But anyway, the modern AI, you see here in this particular chronology, one very important thing happened in early 2006, that is called deep learning. The concept of machine learning and deep learning is not a very old one, around 2005, 2006, by Geoffrey Hinton, first, developed it. And then onwards, a lot of things are happening. And the previous AI and the present AI is not the same thing. Meanwhile, in the early 2000, a paradigm shift had happened because the concept of machine learning came. Machine can learn by itself, it can determine the pattern, and it can be done automatically without creating any rule base or knowledge base. Previously, it was knowledge base, rule base, inference engine, a lot of different components were there, and it was very tough to develop rule set for each and every activity, each and every domain of human life. So machine learning made it some kind of generalized. For any problem, you throw enough number of data, machine can learn the pattern, discover the pattern, and can do the things. So the present, artificial intelligence, the mainly the machine learning is not synonymous to artificial intelligence. Artificial intelligence is a bigger domain. Machine learning is a very important component of that artificial intelligence. The major job, the heavy lifting work are basically done by the machine learning processes, and this process is data driven. I'm giving you one simple example. Say, for example, I want to categorize all Indian publications by their affinity to sustainable development goals for a given country, for a given set of institutes like all universities, all IITs, or a given organization like University of Kolkata. What's the research focus? And can we categorize research publication by their affinity to sustainable development goal? And it is impossible. So far, if you take the SDG came in 2015, so 2015 to 2025, 10 years, we have published almost 40 lakhs of paper in the country. So how it is possible to manually categorize and classify 40 lakhs of research publications? There comes the role of automatic indexing, automatic categorization by utilizing machine learning. So we can give a vocabulary, say for example, all SDG goals. We can give a set of training data, say for example, 20,000 to 1 lakhs of data. We manually classify that this particular paper belongs to goal number 1, goal number 2. This paper belongs to both goal number 10 and 11, and that way. And you train the entire system with that 1 lakhs of data. So machine will learn the pattern, and then it can predict for an unknown paper that in which SDG category or goal this paper actually belong to. So this particular methodology can be applied for clustering, categorizing. For example, you just imagine your mail, Gmail, or any mail you are using. There is a folder called spam, and automatically you find, sometimes wrongly but most of the time correctly, that all kind of junk mails automatically machine categorizing and placing under the spam folder. Who is doing it? Who is determining that it's a junk mail and it should go to the spam? The machine learning, my dear friend. It learned through training that how to go through a particular mail, how to determine whether it's an important mail for the client or a junk mail or a promotional mail, and they will send to that. And nowadays there is also a tab called promotion. So all kind of businessmen coming to you, different kind of promotions and other things, advertisement, they goes to the primary, that promotion tab. So who did it? Who does it? That's machine learning, because that is also a kind of clustering, that is also a kind of categorization. So that is knowledge driven, and a marriage of knowledge driven and data driven AI. First you giving a knowledge, this is the spam, this is promotion, this is primary, and then you are training with a few mails, and the machine learns how to determine. Sometimes it commit mistake, or for the first time a mail is coming from some unknown email ID, and that is important to me, so it landed to spam folder. But very few, and day by day it is decreasing. Previously it was more and more and more, and nowadays you see the wrong landing of important mails in spam folder is minimizing every day. So machine is learning more and more, because when you are changing the location of a particular mail from the spam folder to the primary button, primary mail button, machine learns that okay, I committed a mistake, and that time next time it won't do that with that particular email ID. So everywhere, every bit of your life is touched upon by some kind of AI. Maybe it primitive, maybe it very advanced, and this is data-driven AI. And what's the relation between this AI and ML? Artificial intelligence is the simulation of human intelligence in any machine. It's not only computer, but preferably in computer. Human intelligence in your car, whether car can drive without a driver, and so on. So it's artificial intelligence, simulation of human intelligence in any machine, any mechanical device. And what is machine learning, what's the relationship will be coming. So if you think in this way, this artificial intelligence is a big area, and what not included: computer vision, image processing, image generation, video production. Machine learning is doing the heavy lifting job. And within machine learning, the most advanced machine learning techniques is neural network. We took almost 30 years, computer scientists took to reach to this beautiful model, neural network. Within neural network, the most promising model is TensorFlow, developed by Google. And within neural network, another model, as I given that in 2006, Geoffrey Hinton developed that model, deep learning. So deep learning is another part within the neural network, and within deep learning there is a model called transformer model. And all of your present interest in AI is because of this model. And transformer model, colloquially we call that large language model, and like GPT, BERT, and so on. So GPT developed by OpenAI, BERT developed by Google, Llama developed by Meta or Facebook. So these are the relationship between artificial intelligence and machine learning. So machine learning, you can say, a method of data analysis and determining the model, or building the model and determining the pattern. So how machine learns? Let us say there are two kinds of major learning by the machine. One is supervised learning, another is unsupervised learning. So suppose I gave machine two sets of data and told machine this is a group A figure and this is group B figures, and I have given a new figure which not member of any of these two group, and asking machine that you learn from these two sets of data. These are label data, because this data I have given group A level and this data I have given group B level, and asking my machine that this new figure, in which group it belongs to. Can you tell her? Can anybody tell me that this particular new model, in which group it belongs to, group A or group B? And what's the reason? Because machine is also learning like us. Anyone, please? Do you follow my question? No. Okay, you see here, The logic behind the answer for the machine is that, uh, am I still connected? Not getting any sound of anybody. Yeah, connected. So you see here this the group A and group B differs. In the group B, these are lines and there are no areas between within the figure. And here every figure has got an area within. So this new figure got an area within. So machine will say that okay, this particular unknown figure possibly belongs to group A. So the same way we apply our logic and go for different kind of classification, clustering. So this is called supervised learning. Why supervised? Because I am giving a supervised data set. So I already labeling this is group A. So some kind of logic I applied previously. This is group A and this is group B. So A group, B group, and machine already got a label data. So this label data, when you are training a machine with a set of label data, this is called supervised learning. So what is unsupervised learning then? I am not giving any label to the data. Only raw data I am throwing to the machine and telling machine that you classify or categorize according to their intrinsic attributes. So machine learns the pattern depending on the size of the bubbles or density of the outer layer, etc. They prepare the feature or characteristics and they group automatically into three, like A, B, C. So here, this is this kind of learning without any kind of prior knowledge. I am just giving data by learn by yourself. So this is called unsupervised learning. And what is the difference between this? In this area, supervised learning, I have already told my machine these are red, this is blue, and this is green. So I'm giving you dots or bubbles, and you categorize it. So I'm labeling the set with red, green, and blue. Here I am not giving any kind of label, but still it is actually doing the job. Although little bit of mistakes are there in compared with the supervised learning. So when supervised learning is the most preferable form, if not, always it is not possible to go costly level data. So there you can also utilize unsupervised learning. And uh, all the machine learning techniques can be different, can be uh, divided into four groups: supervised learning, unsupervised learning, a combination of, this is most popular, a combination of supervised learning and unsupervised learning, that is called semi supervised learning, and reinforcement learning. So reinforcement learning, you are using supervised, unsupervised, or semi-supervised, does not matter. You give machine a set of 10 questions, machine correctly telling the 8, 2 was wrong or 2 were wrong. Then you are telling the machine that these two were answer were wrong, and this is the reason, and what mistakes the machine committed I am explaining. So from that particular human feedback, reinforcement learning through human feedback, what we call RLHF, machine is learning its mistake and next time it will not commit that this one. So this is called reinforcement learning, and nowadays it's very popular the to train machine further. And this is the relationship. Machine learning is the core component. It is actually merged into artificial intelligence framework, and then artificial intelligence frameworks is attached with different kind of application suite, like your mobile keypad or your word processor or your email and so on. And there is, as I said, that there is a little bit of AI in everybody's life. The moment you are using any kind of digital services, there is a little bit of AI. For example, this one, when you are typing, in your mobile keypad, you have seen that mobile keypad can predict that what could be the letter. It is the or thanks, and you can stop typing and take the word. So this is also AI, but limited AI. You give a few character, it can predict the word. That's the thing. You type a few letter, and it can predict the word. And that technology, that is GPT-1, So that technology extended to GPT-2. Suppose this is my Gmail account. I am writing a mail. I have written already 2 lines, and it can predict the third line. So the moment I type when is, the computer can give me a suggestion for the line, a good time for it, because in this 2 line it got the context, it got training, and it can predict the next line. So I'm giving a paragraph and a line can be produced. The model is called generation 2 or GPT-2, and that can be extended to our word processor also. But the real difference came in GPT-3 mode, because if you compare the number of data parameters or data points through which the framework is trained, in case of GPT, in GPT-2 it was 1.5 billion parameter, and GPT-3 is 175 billion parameters. So every year they are increasing data parameters. And what are parameters? Parameters are not data. Parameters are combination points of data. For example, we all know how to make a cup of tea. We need water, we need sugar, we need milk, we need tea. But can we all make the same quality of tea? What magic? Because we have got all kind of ingredients, same ingredients, but we make different quality of tea, different kind of qualities. So I can guarantee the tea I prepare, you can't drink even. But some of you definitely, prepares tea, which is lovable by everybody. Everybody prays that it's a beautiful cup of tea you have prepared. Why? Because, my dear friend, the data parameter, the combination, I don't know the right proportion of milk, tea, sugar, water for 3, 4 people. You applied the right combination of tea and every ingredient, and you have prepared a beautiful cup of tea. So that combination, that data points are called parameters in large language model, and it is trained with 175. It was trained with 175 billion parameters when released in November 2022. And what else it can do apart from writing flawless English text or multilingual text? It can analyze a spreadsheet, it can search, and you already know different other kind of tools, generation of image and everything. And here you see, because of these data point parameters, success in increasing data parameters or data points, uh, these models are basically madly, increasing the data parameter. GPT-1, GPT-2, 1.5 billion, GPT-3, 175 billion, GPT 3.5, same 175 billion parameter, but with RLHF, reinforced learning through human feedback. And GPT-4 model, what you are presenting, it's 1 trillion parameters. And the more and more are the data parameters or data points, more and more energy it is costing. And yeah, I have a very simple question here for builder of this large language model. Suppose you want to go to the moon. So do you prepare a ladder, long ladder, and every year you are increasing the height 100 feet and finally reaching to moon? No, no. We always try to develop a new technology which can beat the escape velocity, and we can launch rocket to the moon. So that technology is missing here. They are thinking that development of new models with large number of data points is the only solution. But I think it's not. Soon, within 2, 3 years, another epoch-making technology will be coming, which will reduce the planetary cost of the present generation of AI. These are very, very costly in terms of planetary resources. And increasing number of parameters every year is not the solution, because as for the right reason, we never developed a ladder to reach the moon. We always develop new technology to beat escape velocity. So that's my personal opinion, of course. But anyway, up to this GPT 3.5 or GPT 4.0, a lot of tools we have developed, and many of these tools you are already trained with, like tools for human productivity, video generation, image generation, writing, beautiful, flawless, grammatically correct text, designing, different kind of chatbots, marketing, and different other what not actually. You name it, we have it kind of situation. So it's a huge, huge landscape. No one can even the number of AI tools human race produced so far within this 3 to 4 years. No one can learn all of this tool in his or her lifetime. Not possible. So my point is that definitely we need to, because wondering is one of the precondition to develop something new. We need to wonder how beautifully these tools are developing. For example, say this is a video produced by an AI tool. I asked this particular tool, can you predict the future of public transportation? Because many of us who are daily commuting from one place to another place, public transportation is a huge problem for all of us. So with that frustration, I asked a video producing tool that can you produce a video to tell me the future of public transportation, and you see what it produced. I don't know whether it is hyperlinked or not. Okay, so this is the tool it produced actually. So this is a taxi. It all on a sudden appeared from the sky, and you see the details of this technology, how it is working, how it will work. Although we simply do not know whether it will happen or not, but you see that it can predict, and some of the technology design, everything is so crystal clear and in minute details. Anyway, so this is the video produced by the system, but not everything is a success. Okay, so why? Because here you see this is GPT 3.5. It is working fine. I can generate lot of tunes and techniques, ask different kind of question, it can answer. And it can, this is the Gemini. I given a tricky question: what's heavier, a kilo of feather or a pound of steel? So it can understand that I have given two different units, so they are two different weights, and it previously ChatGPT was not able to answer this question. It is bluntly saying that both are same. So I have just changed the unit here, a kilo of feather and a pound of steel. So it answered correctly. So don't have any problem. So these are all success stories. You have a full-fledged class on LEC. So this is how we are utilizing this GPT-3 model in a search engine, which can summarize 4 top papers and give this thing. You already tried that. Another one's the perplexity.ai. LEC is based on around 125 million papers from Semantic Scholar, and perplexity is based on this paper, scholarly paper, as well as different kind of feature article, newspaper clippings, and so on. So it can also do the same thing, but the scope is much broader in comparison with the LAC. So these are the success stories. And another success story is that we can prepare or develop any kind of image. So the same OpenAI developed a tool called DALI in the loving memory of Salvador Dali, a famous Spanish painter. So I can go to this particular site. I can ask a particular situation, and it can draw a picture. For example, I asked this AI that please give me a design for a reading room in a small library with soothing color furniture, scope of natural light, and a picture of S.R. Ranganathan on the library wall. This wall. So here it draw it beautifully. The colors are soothing, scope for natural lighting, and it knows who is S.R. Ranganathan, find the picture and paste it on the wall. Very good. But the very next moment, it may, frustrate him. How? I am asking that Mother Teresa is fighting against poverty. So this is the picture created by the same tool which created a beautiful reading room for me. So here you see this picture is a laughable stock, but more problematic in the biasness. You see here the biasness. What is the how it took the fighting in a wrong sense? That is a different story. But the more important thing is that it is equating poverty with African children's, and that, my dear friend, is called algorithmic biasness. Don't forget that algorithms are produced by human beings, and our own biasness will be reflected in our programming languages also, our algorithms also. So this is an dangerous trend in AI. First of all, misinterpreting a situation. It does not know simply how to keep the word fighting in the proper context in Mother Teresa and poverty. It still need to learn. And second is the how it knows that poverty is associated with African children, and how who dares to utilize the picture of children's in a reproduced image. Who given that particular program license to do that? So there is a dangerous side also, algorithmic biasness, wrong connotation, and different kind of misuses. So finally, what we are mainly targeting is the responsible AI, and responsible AI can help us in different kind of productivity. But if the AI is not responsible, like nuclear technology was not responsible, and we all know the result, same thing is going to happen. No technology is bad or good. It is only that how we are utilizing that technology for different purposes. Whether the technology is biased towards some privileged class of the society or not. The present AI, like any other technology, is Eurocentric, Christianocentric, homophobic, and male dominated. The same biasness we found everywhere in the world are also available in our AI algorithm. So don't forget it. And now, with this little bit of caution, we can now categorize our tools into different groups. Okay. So first categorization is that the tools you have already learned, the what we call the group A tool. No installation required, no further training is required. You just know the URL, you go there. Most of the available in free tier, and I already told you the problem of the free tier. So there are different kind of AI enabled search tools like Semantic Scholar, then question answer enabled search tools like Elicit, Perplexity, literature gathering tool. So from each and every group, I will be targeting one. So here in the AI enabled tool, I will be targeting Semantic Scholar. Question answer I will avoid because you already having an idea with Elicit. Then in the literature gathering, these are all AI enabled tool. I will be targeting research traffic, and I will show you through demonstration how it is possible to collect within minutes all related literature, and can reuse that one. And different kind of browser extension. These are very easy tool. You all know how to install browser extension, but here you can try this one, core recommender. I'll show you that uh, when you are finding a particular paper and that paper is available in closed access commercial domain, so core recommender can give you a list of equivalent papers available in the open access, a beautiful AI enabled recommendation engine. So that we will be trying. So this is the group A, but I am not quite a fan of group A of tools which are ready-made tools, and we already learned a lot. What I am targeting, and these are the tools what we are using: literature search, grammar checking, writing, qualitative analysis, quantitative analysis, citations gathering, and so on. So this we have already covered through different classes. What I am interested here to little bit extra, one step forward. You are having, your only condition is that you are having Python installed in your machine and Python available in the path, system path in your Windows machine. Linux machines are already equipped with Python and Perl, so they don't have to do anything. In fact, every day I'm finding this in AI ML, Linux is much easier than Windows. But anyway, that's a different story. So here what we will be starting, automated systematic review, AS review, open source, an open source tool, beautiful open source tool where we can get first time and a first hand experience how machine learning works, how I can train a particular model and how I can be benefited by this training. So that is a very, hello world program kind of thing for an for the AI literacy. And that's a very robust tool which can teach you the very first lesson of machine learning. So that we will be trying. Bibliographic data wrangling, there are different options available, like named entity recognition. I can throw a chunk of text and it can identify the person, concept, everything related to that one. So sometimes it may be very helpful for your literature review. But other advanced level applications are sentiment analysis. I can throw a text and it can tell me whether the text is positive in nature, negative in nature, or a neutral one. So, like book reviews, whether the review is a positive or something like that. Machine translation, sometimes it is very important for an individual researcher, because you see English is the predominant language in science. That does not mean that every piece of knowledge is available in English. You may have a very good paper in Portuguese language or in Spanish language, no English equivalent is there, and a translation service is very costly. So here we can utilize open source machine learn translation framework, which are again machine learning enabled framework. I will try to show you a little bit how to utilize that machine translation thing. And then the complex applications automated clustering and categorization. Here I will try to focus that how it is working, and how we can apply that one in clustering our research papers. Suppose for literature review you gathered around 200 papers. So how can you cluster that in different groups for your ramification of your presentation? So how to do that? And a very recent techniques called RAG, retrieval augmented generation. Okay. So I'll be coming one by one. So let's start with group A tools. So here you already know something, but I would like to show you a real, methodology for your literature review. So the plan is here is that when, and my suggestion to all of you, that when you are targeting a particular area, like you are a PhD researcher or completing your PhD, or you are writing a paper, you are already having your PhD, you are an experienced teacher, and you are exploring something new to write a paper or to do something on it. So don't collect 100, 150, 160 papers. Gone are the days for that kind of, mindless work. Collect only 10, 15 uh, references or paper details which you think very important for your research. And no one can guide you there. I cannot tell you that these 10, 15 papers are very important for your research. Research is your own adventure, own path to travel. People can act as an intelligent, this milepost, but the traveling the path is your business. So it is you and you alone to solve this problem. That 10, 15 papers you go through it, determine whether these 10, 15 papers are core papers in your domain or not. If you are selecting correctly that these 10, 15 papers are your core paper, Then there are tools on the top of that 10-15 papers. It can give you a plethora of literature, and that you can collect manually and bring to your reference management software. And finally, you can throw that collection to a visualization tool, and that can give you an excellent idea that what this particular collection related to, what are the major focus, what are the most important phases, how research is shifting its focus over the time, everything it can do for you. Okay, so let us start. And do you need any tea break or something in between so that I can plan accordingly?
So, if possible, can we take a 5 to 10 minutes break?
At this point or later on?
Like
Now? Okay. So anyway, then take a 5 minute break, quick break. We will be assembled here at 12:20. Okay?
yeah.
Fine.
Thank you, sir.
Okay. Okay. Can we start now?
Yes, sir.
It is visible?
Yes, sir. Visible.
Okay, fine. So here we are now going some for hands-on demonstration, and let me explain what I am planning. So here in your folder, I have created a folder here. I have one particular document set. This is only with 16 number of bibliography. So I am now, if you don't see and it's not matching with the display, then please report me, because sometimes there is a delay of 1 second or something like that. So I am moving to my Zotero. Let me increase the size of this terminal. Zotero, you all know that available for both Linux and Windows. So now onwards everything is same, and this is my Zotero, and I am creating a collection by utilizing this 16 number of bibliography. So what I will do, I will go to my library and create a new collection, and new collection I can give a name, say, or you can directly import also, import the collection. Then it's a file of bibtext file. So this is my bibtext file. So this is the bibtext file .bib extension, and it includes 16 number of this one, these references. So what I actually asked you, that you try to have a few number of core papers, and this particular domain is related to machine learning applications in generating different kind of library services, knowledge organization. So I collected a set of few. Let me rename this so that I can remember. So this is my CIRM version 1. So this is version. This versioning is very important so that I can understand that what is what, which version, what is the latest version, and so on. And this is ranging from 2003, 1998 to 2023. Okay. So what to do with this core 16 items? Core actually is a relative term. It will differ from a, person to person, which is a core set of documents for your research. I am not in a position to tell you. So it is you and you alone to determine that these 15, 16, 20 are my core papers, but don't go beyond 25. 25 is just enough. Around the golden mean is around 15 to 16. Now my request to all of you, from this one you can export your collection in a simple bibtext format. So this is my simple bibtext format, and then I don't want to export notes, only the DOI is enough, and I am saving this one as CRM v1.pip in my same folder. Okay, save it. Then we will come back again to Zotero or any reference management software you are using. Mendeley also can help you in doing so. But remember, Mendeley is a freeware, not an open source. So now I am going to my tool called Research Rabbit app. So Research Rabbit app is, you just need to register there, and I am creating a new collection, CIRM V1. So now CRM V1 will be there, and there is not a single paper available. I click this particular collection, I go there. I would need to add papers. The moment I click add papers, I can add by title or DOI of the papers, or more, productive is that you have already collected your paper in Jotero, you have given the references, included the references. So from there you can upload a BibTeX file or RIS file. So I have a BibTeX file, and this is CIRM v1.bib. I'm adding this 16 paper. Okay, so this 16 paper added, and you see the beautiful process related with this tool. This is a combination of the typical or traditional citation reference networking as well as AI based recommender system. So the moment I given this particular tool an input of 16 references, what I think code paper, it determined that these are the similar network. These are the earlier work what I missed, means pre 1998 paper which are related but I missed, and what are the latter work, that means my reference spans belonging to 1998 to 2023. So after that cutoff date, how more and more modern research appeared in different journals. It is also saying me that these 16 papers are authored by 55 number of authors, because most of these papers are multi-authored paper. But I can suggest you another 658 authors who are working in this particular domain. So you see the beauty of this tool. As I said, it's a combination of traditional citation reference networking. You all know when you are writing a paper referencing some author, so you are the citing author, and the author you are referring, the work you are referring, that is the cited author or cited work. So there is a linking a network between the cited document and citing document. So on the basis of that link and on the basis of different kind of AI recommender engine, it actually did it for me. So the moment I go to the similar work, it will tell me and beautifully given me a network of documents. So here you see this, we need to understand that how this graph is represented. You can see here there are three prominent colors in this particular graph. One is the green. Green has two varieties, deep green and light green, and another is blue. Blue has two varieties, deep blue and light blue. So here it is saying that one of my paper is highly connected, but I missed all the important major bubbles. So here each node and bubble is representing a paper. The first name of the author, the moment you are pointing or hovering your mouse pointer here, the first name of the author will be coming, and the bigger bubble and denser bubble are more impactful paper in this network. What I actually missed. So green paper I have included. These are in my network, but I missed a few other important paper. For example, this paper. So the moment I click this paper from this graph, so the details of the paper will come. It's a paper on ethical AI. What I missed, I can add to my collection. So I was having 16, now it is 17. So in this way, I can check other central notes and papers which are bigger and denser, and I can read the abstract. And as I said, that you are the authority here to go through this paper. Some papers are hyperlinked, you can check the full text. For example, this paper PDF is available. So at this particular point of time, you are also getting which paper is open access, which paper is not. But abstract is available for each of this paper. So if you think this paper is a good paper, you can add to your collection. Then suppose this paper is a central paper connected with lot of other paper, and in this way I can move on adding other paper. This is an isolated paper, not yet connected, but you can check all of this paper. So now previous, you see now my similar network is different, earlier work is different, everything is changing the way I am adding it. So in this way, I can go on adding different other paper, and within 10-20 minutes, you can collect all the related paper. And again, you click on the similar network to check how it is working and what more papers is coming. And more you are including, you see your network will become more and more tight knitted. So here again I am finding a very important paper. What I mean is in this way. And now say earlier work. So these are all earlier works, before 1980 or related to the oldest paper in my collection. I can click, I can add a few paper. These are the latter work. So every time you see this network is becoming more and more close knitted, and you can click, you can add, and that way. So here I am not giving time to include, but it's always advised that you read it, you see whether the abstract is related to this paper. If not quite determined, can check the PDF, and in one single interface you can determine all of it. Now this you are having now 23 number of papers, so you can close any of this network at any point of time. So again, you see, we started with 16. Now I am 23. Now I can check these 23 are authored by 121 people, but it can suggest me that these are the very prolific researcher in the domain. Any of these author you can select, and then you can find his or her paper. Say for example, this person I know, Suresh Venkatesh Subbayam. So the moment I click what are the published work of Suresh related to this one, I can see that Suresh has around 166 number of paper. I can see all the abstract of the paper right here. I can check this abstract right here and think that okay, suppose this black box model is I think it is important for me, I can add to it. So from any of this collection I can go on adding number of papers, and very flawlessly right from here I can use this platform which is built on the top of AI principles to connect related and similar papers together. But as I said, this network performs better if you are already quite determined that these are the 10-15 core papers and I'm quite sure about it, these are the core papers of my domain. Then you can create a beautiful network of related papers within 20 minutes. Even I am not reading here to save the time, but please read, and sometimes need to check the full text of the paper. It is not a very easy job to determine whether a paper is good for your research work or not, or whether it's a code or not. But give that particular due importance. No search tools, no search engine can give you this facility. From a single window search interface, you are getting similar works, related authors, later works, earlier works, everything, and very easily you can add or remove from your selection. At any point of time, you can close any network. It's not a big deal. And when suppose now I have 24, I want to add another one paper to make it 25, suppose, and abstract I can see here. And here from the network you can take, or from here you can take. The moment I click it here, the particular paper will come and I can add to my network. So suppose what to do with this 25 records, I can again click BibTeX, this export paper, and I can give a name, say in the same folder I am using my presentation 2024 CRM, and I am saying that this is CRM v1.b. So v2.b, and you can also write within bracket these are having 25 references. Now what I can do, I am already having this v2.25 number of document. What I can do, this 25 document, this 16, so I can delete all this 16, remove all the items or move item to trash, so it becomes completely blank. I can clear the trash also, and I can come back to CRM v1, and this 25 I need to have here. So I'm showing you another process to adding. So suppose when you are uh, uh, converting a set of references into your already existing folder, then the process is that you open your bibtex file. This is the 25 bibtex file. Select all, copy, come out of this and come to your Zotero, and now you say import from clipboard. So what you have copied, that is now that 25 will be coming to this folder. So it's a very good way to manage that how we can do that. So Jotero have other features also. You can search the availability of the full text of the paper, as well as you can check that their DOI and so on. So here you see, I would like to check availability of the full text file of this one. So select all, right click and say that find available PDF. So it will automatically, on the basis of the DOI value, it will try to fetch, try to find out the uh, open access version or the preprint version of the paper in any of the repositories of the world, and if available it will be adding the paper to your collection. A very beautiful service that we can utilize. Another interesting feature with this with this AI and other thing, Jotero is also improving. Sometimes suppose in a code paper you are checking that this is one of the code paper, a review kind of paper, very important references are included there. I want to include that references directly into my collection. That also you can do now. Let me show you. After the process is finished, it is finding a lot of full text and adding this one. When it is finding, it is giving me a green mark. When not, it is giving me a red cross. So in this way, the process will be completed. So I'm canceling this one because you already know how to do that. So how to do that? You select all, right click and find the PDF. And these are the PDF file attached here with submitted version, then full text of the paper is open access. So right from here you can manage your entire collection. But what more you can do with the Zotero with this very simple plugin? Say for example, this paper PDF is available, or this paper, say this paper PDF is available, putting AI ethics to work and so on. So I can open this one, that open PDF. So another tab will be there to open the PDF file. And you see the beauty here. Mostly we do not use these features in Jotero, which are the recent addition in the plugins. So here this is the paper, full text paper available in open access, and this paper has got definitely got a few set of references. So these are the references, you see 121 references, and my system can extract all of these references on the top of their DOI value. So here you see the right window, here information, tags, etc. There is a tab called references. So all the references are also coming here, and any of these references, suppose I think that this 15 number of references or 20 number of references is important for me, I can add it, say 15. So I can check the paper, what is the paper title, who wrote it, the abstract of the paper. And if I think this paper is important for me, my dear friend, that's a beautiful magic we can do here. I can simply click plus sign to include this Kajin paper in my collection. So it is now searching the DOI and creating an item. And the moment I close it, you can see the Kazim paper came. Amazing, is not it? So what we are doing, tell me, it's not raw Zotero, default Zotero. What I did here, I adapted a set of tool, the plugin we call, say here you can see tools, then these are the tools I am using, add-ons. So this is the add-on which is doing this one. this Jotero reference extraction. A Chinese group of people developed it, available in the GitHub, and the Jotero version I am using here 6, but Jotero 7.0 is also released. So both, for both the version it is working. I checked. So Jotero reference plugin you search, you how to install a particular plugin. You just go to tools, add-ons, and here you will be getting a gear button. Here you can install add-on. So you need to download a particular file first. Suppose this particular plugin, open PDF for Jotero. So a lot of plugins I am using, Sita plugin, but the most these are different purposes I am having. It's not required for you, but this is very important. So suppose a very good paper, a core paper in your domain gives a lot of important references that you want to include directly into your collection. So you can do that by using this referencing uh, plugin, Jotero reference 0.5.8, compatible with the latest version, both the 6 and 7. And you can go to this particular place, install add-on from file, that downloaded file you select. These are basically all XPI file. Say my XPI file is here. So create a separate folder like I have created PSM plug. So all of the plugins I am using available, and any one of these when you are downloading the XPI file, you select the file, it will be added to your system, and the system can do magic for you. Say another full text paper, suppose I am selecting this one, open PDF. So this paper got around, let me check how many references, around 70 references, and automatically this 70 references you see extracted here. 70 references. So any of these references, first I check. If I hovering my mouse pointer here, it will give me the title and abstract and so on. And if I satisfied of, if I think that this particular paper is helpful for me, I can directly, suppose this paper, another paper I want to add of Silter, value levers building ethics into design. Okay, so I can take plus sign simply. So it is Silton paper. So it will first search a DOI. If available inside the Jotero dataset, then it will add it. And if it is available directly the DOI value, it can do that. So let me check any of the paper. Suppose this paper 40, paper number 40, I think important. So paper number 40 is this L Irani. DOI value is there, and I can click. So it is creating an item. So the moment searching and creating of item, adding item, it will be showing, and then when it is over, I can have Irani here. You can see. So Irani paper came, and in full context. So that is the beauty of advanced utilization of Zotero. If any of you are not finding this Zotero reference extractor, please contact me. I'll be sharing my email with you. I'll be sending you through attachment. So don't worry at all. So this is one thing. Another thing is that suppose I have, in this way I have gathered, suppose a few number of documents. So what to do with that particular document? For example, by applying this process, I have created a file with 8,000 plus records on a given project. So I recently got we're dealing with the project, ICSSR concept project, the library services for LGBTQI population, that whether libraries are gender neutral, are we treating people of from different genders equally, our knowledge organization pools are neutral in nature, or so on. So that kind of thing. So we collected the following the same technology what I am showing you here, around 8,000 record, 8,333. So I'm not telling you that you do your literature review with the 8,000 plus records. No, You select 122 papers for your literature review, for your thesis, or for your paper. It can be around 30 to 40 papers. But that 30 to 40 papers you can utilize to create a large sum of collection. For example, our purpose was to collect every bit and piece of writing on the top of this LGBTQI enabled library services. So we collected around 8,000. So it's a huge, material, set of materials, references. We exported that one in RIS format like BibTeX, and I can mechanically, check what is the focus of these 8,000 records, because humanly it is almost impossible to go through 8,000 records and determine the ramification, division, subdivision, important phrases, important words, statistically significant words, everything. Do not try that. You are not, your brain is not meant for that. That is a worst kind of use of your brain. Your brain is meant for inferencing, and the different tools are there to give you data. So another interesting tool apart from this research rabbit and other thing is Voss Viewer. So if I go to Voss Viewer, you see here again, it is compatible with both Linux and Windows. Tactically, I have utilized only those tools that you can utilize both in Linux and Windows, because I know that for different set of reasons, you people are using Windows platform, and Linux is not quite popular with you. So don't worry at all. I am nobody to advise you that which operating system you are going to use. So here, this Voss Viewer version you can download. Voss Viewer here. It's simply a jar file, nothing more than that. You see here, the moment I go here, it is saying for this is for Windows, this is Mac, this is for other system is Linux. Linux is still other system for people, unfortunately. But anyway, so these are the same thing. So you can download your Microsoft Windows version. Only thing is that you need Java. So my suggestion to all of you, in your machine, you install two programming environment. One is, you don't need to know programming, no requirement. You need to develop the programming environment so that your downloaded software can utilize that. So go for Python and go for Java. Java latest version, Java 11 you can utilize. So download this jar file, and in Windows you can right click with the file, open with Java, it will open. For Linux, we downloaded this version, and I can start my Voss Viewer. Okay, let me close this one. I can start my Voss Viewer. Here you can see. Let me open another window. So this is my command prompt. So I'm trying to utilize another window. Cd Voss Viewer. No, V capital or V lowercase, I always mistake. Okay, so this is VOS Voss Viewer. So here in the Voss Viewer, I have a simple script file that is actually running this jar file, this Voss Viewer jar file, this one. So it will open for you. Now onwards, everything is same. So here you see this Voss Viewer jar is open through Java. Now this is a software with its own interface, and what I am trying to do now, trying to get a focus, the research focus over the period of time in my domain, that is the LGBTQ enabled library services. So what I can do, I can create a map based on textual data. I'm going to throw the title and abstract of the references. Then it is asking me that what kind of file you are going to use. I have data only in reference management format. So read data from reference manager file, RIS, EndNote, and RefWorks. So easily you can see I can export any of this collection in RIS format. Export collection, and here I can select RIS format. So that's simple. So when you are utilizing Voss Viewer, your data must be available in this one, this RIS format. So I have done that. So let me select this one. Now it is asking me where is your RIS file. My RIS file is under this media. This is a external hard drive I am using. Oh, this is, so I'm just going to your folder, my presentation 2024. This is the CRM folder. So this one. So here I am having this 8K plus RIS file. So click OK and click next. So now it is asking that what to analyze, only title, only abstract, or title plus abstract. Go for title and abstract and keep everything default. Then it is extracting all 8K records and applying some kind of machine learning backend based on TF-IDF algorithm. TF-IDF stands for term frequency and inverse document frequency. I can go for full counting. Then it is saying that what will be your threshold value. This is very important. So threshold value by default it is 10. So it is saying if you set it 10, there are 42,000 terms are there, but 12,708 are actually meeting the threshold. So 12,000 is a very big thing. I want around 300 to 400 maximum number of focal term. So I can increase the value. And you see, the moment I increase the value, number of documents are decreasing. So this threshold value means a term or phrase must appear 15 or more times. So minimum threshold value is 15. Let me set it to 25. So the moment I set 25, it is 500. Let me set it to 30, 448. Okay, 30 is good. So let me set to 30. So you need to do a bit of permutation combination here, that which gives you the good graph. So threshold value I have determined 30. Next, then it is saying number of terms finally will be selected 269. This is calculator. I don't have anything to do here. Then next, so it is now creating different kind of frequency. And suppose it is giving me some of the document, I don't want this MSM and abbreviation or different other kind of term I can. And don't forget the domain. So you may see that a lot of uh, terms are coming, unwanted terms are coming, but don't forget the domain, please. So I don't have to do anything. I can check out some of the things I don't want. Say rise, I don't need. So this kind of important phrases. So click finish. And the moment you finish, you see you are now having a beautiful clustering of your papers. So it is actually giving that all of your papers I can cluster into four primary zone. Green zone, so here you can see it deals with different kind of sexual identities. And I am telling again, you please don't forget the domain LGBTQI for library services, or library services for LGBTQI. So these are all different kind of transgender, the green zone. So this blue yellow zone is means basically the different kind of users. This deals with the library-centric papers, which deals that advising different kind of services, biasness in knowledge organization, and these are basically different kind of knowledge organization theories for LGBTQI. And any of the domain, if you hovering, say for example, how gender is related to all of these, the moment you will be getting that how a particular phrase is related to a network with other different kind of categories. You can take a snapshot, you can include that in your literature review as a snapshot, that this is the clustering, and on the basis of that clustering you can report your literature review. Because in literature review, no, ramification is very important. So that ramification part, it can help. You can determine that okay, these are the four groups, and within the blue zone again, these are the subgroup I can create. Within the red zone, these are the subgroup I can create. So on the basis of that, you can collect related papers and prepare your literature review. It will give you an idea. Then I also told you that it can tell me that what are the out things and what are the in things in a research domain. So this LGBTQ related library services, the paper actually from belongs to 1971 to till date. So it's a long span of 50 years of time, almost 50 or more than 50, 60 you can say. So what actually in these 60 years went out of the focus and new things came into focus. So I can go for this overlay visualization. So what it will do, it will now classify all of my paper from the darker zone to lighter zone. So you see these are the darker zone up to 2012 and how these are the in between, and these are the thing. So the moment you check a particular concept, you can readily identify whether it is a modern concept or a newer concept. So for example, algorithm, application of different algorithm to create LGBTQI uh, mm, based knowledge system or vocabulary control system. Algorithm is a new one. Similarly, different kind of other tools like transgender related research in library is a new one. So I can easily identify what are the old concepts. For example, this knowledge organization theories all are becoming the work of 70s, and then onwards that theories are applied by utilizing different computing algorithms. So this is, I'm getting a clear picture of what are the out things and what are the in things. And another one is the density visualization to determine the gaps and overlaps of research. This is true for every domain. In some particular point, there are lot many research paper overlapping, and another one, no one actually ventured into that domain. So you can easily identify that where lies the gaps. So here you see in between these interface areas, this library related to different kind of gender studies, there is a big gap between here. So most of the library research until now were not focused on gender equality, gender-based vocabulary control, and so on. So in this way, I can determine that these are the overlapping zone and these are the gap zone which we can target for our research. So this is a very beautiful, a small piece of software that you can utilize to cluster, categorize, visualize your entire research from a, what we say, uh, a, a bird's eye view, what I can say, a panoramic view of your research you can find from here. Okay, so these are the methodology you can try. Collect a set of 10-15 documents, go to research rapid, collect that, and utilize different kind of retrieval engine like semantic scholar and so on to get the data, and then visualize your research, identify your gap and overlap, and start exploring. So that could be a methodology, and nowadays people are successfully applying this methodology. Let me show you one of the, our scholar recently submitted a project, a research, and let me show you that thesis. So suppose this is chapter 2, literature review. And here you see how cleverly she is using these tools and technology to write the literature review chapter. So these are all classics, first she discussed in the domain. It's a and the spectrum of literature review. So spectrum of literature review, all the 130 core objects, how these are connected through citation network that can be uh, determined by the Voss viewer, that can be produced. Then all the 130 papers see actually given XY coordinate. So X coordinate actually determine the year of the paper, and Y coordinate determine number of citations received by a paper. So on the basis of that XY coordinate, how papers are related with each other to prove that this is a very closely densed, set of 130 papers. And then how could you determine or classify this 130 papers into 4 different zones? And finally, these are the focal terms or local area on the top of this 130 records. Then that 130 records extended mechanically to create or collect all kind of related work from a open database called openalex.org. And finally, she collected a set of 1,000 papers, around 1,000 bibliographic records, and applied that one in this, to determine the entire gamut of literature review. And on the top of this, see now actually setting the ramification. So one section is subject indexing, another section is say this way. So sometimes biasness and otherness. So in this way, I just given you that example that we can all use this methodology for our PhD research, for our paper writing, and so on. Okay, so that is one part of the game. Another thing, what in the group B, what I am going to share with you is the automated systematic review, a very clever tool. And first time you will be getting an hands-on idea how machine learning works. Where to go? So this tool is called AS Review, automated systematic review. You just search AS Review. So a Netherlands-based university actually developed it. This is AS Review, and if you go to this download section, you can see here, this is your available in your favorite operating system, Windows. And if you click Windows, it will tell you how to get Python, how to install Python, everything, and how to set the path environment variable. So that's very simple. And the minimum version of Python requires 3.8. The present is around 3.11. So anyway, 3.8 or higher will work. And similarly, I can select how Mac or Linux it will work. And after your Python is there, you just give this 3 command: pip install AS review. Pip stands for Python Information Package Manager. It's a kind of installation tool within the Python. Pip install AS review. Then you can call the tool AS review lab, and in case of any upgradation came, you can simply update by giving pip install update AS review. That 3 simple commands, nothing more than that. And in Windows as well as in Linux. So in Windows, the thing is that Python is not available by default. You need to install it, and you can download, and loads of video tutorials are available to teach you how to do that. So the moment your this 3 command is over, you can come to here. So pause viewer we have here. So now I am going to, or I can directly call my AS review from here. So AS review lab. So my AS review is slightly, typical. I install all kind of machine learning activities here, but for you it is not required actually. So you better go for simply pip install AS review. All necessary models will be coming. As I am experimenting a lot with different models, so I installed everything, and a lot of complex, messages are coming. And you can open it up, either right click on it, open link, or it can be opened automatically. Now, what's the purpose? Let me explain you the purpose. My purpose is here. Here you see, I have collected, initially I have collected, as we are presently involved with this particular project, from Scopus and OpenAlex database, I collected a few core papers on LGBTQ, around 2,000 papers. Sometimes it may go up to 5,000. Your initial days of literature review, you collect everything you are having. So now suppose this 2000, to be exact, around 1897 number of references I collected on the same domain, LGBTQ based library services. Then this I will throw to the system. I will train the system that these 5 things are relevant for me. These 5 things, 6 things are irrelevant for me. Now, on the basis of that minimum training, 5 relevant records, 5 irrelevant records, My system can learn that what kind of research focus I am having. Now it can go through all these 2000, 5000, 10,000 records, and it can rank all these things logically on the basis of the training. So before doing that, let me show you the content of this particular paper, file. So here you see, this is directly downloaded from a merge from OpenLX and Scopus, around 2000 records on the domain. So author is there, author ID, title, year, DOI value of the paper, etc. And please, this is abstract. And please remember the last column. So what we are having in the last column? So the last column here you can see EID. EID is an kind of identifier, electronic identifier like DOI, mainly Scopus is using it. So the last column is AG column, and here we are having a EID value, because this particular file will be managed by AS review to determine and rank the abstract on the basis of my training. So my target is to create or rank all the 1800 plus abstract on the basis of the training, and so that I can take the top 50, top 100 papers for literature review. So what I will do now, this is my input file. I opened my this one, so I can create a project. Let us give the project name as CIRM. Author is CIRM, and purpose is demo. You can write your own, and there are different modes are there. So the most advanced mode with AI enabled things is Oracle mode, so use that. This is default. So now I can click next. So now it is asking that you please add a data set, and you can see that the data set can be added in different format, CSV, RIS, and so on. So I can add a data, uh, select a file. So this is the file, LGBT all 1897. So now it is added, and now it is asking that you give you give a training. So at least one relevant, at least one irrelevant, to warm up the AI. But my suggestion is that please select around 6-7 relevant, 6-7 irrelevant. So I can now start training. It is now saying, before that, suppose this is a document set collected or originated from every country of the world. My major focus is library, my major focus is India, my major focus is classification, cataloging, and so on. So first I am searching that which are the paper deals with library. So all the paper in this particular data sets will be coming with the library, and I can determine that organizing an LGBT library. Yes, this is very relevant. Yes, so it will go to relevant one. So in this way, I can read the article, I can check academic library and LGBTQI student, very important. Now let me search by the country. I want something is there in India. So here you see the homophobic era in India is over. United Nations resolution, then Section 377 in Supreme Court. So all are seeing a shifting in the society toward LGBTQ. So I can say, okay, this is important. Yes, activism I don't want, movement I don't want. Now suppose I want classification, a very important library activity. So you see here, browsing through bias, a very important paper which is saying that our library classification is biased towards, what to say, heterocentric society. So let's yes, and this beyond due, yes. So you see, I have relevant 5. Another thing I want to add, maybe cataloging something. Okay, this is not cataloging. So maybe another one I want to adjust, maybe knowledge organization. Uh, okay, suppose this is the relevant one. Then I need to set a set of irrelevant papers. Say I don't want anything related to activism. My research focus is not activism or LGBTQI movement. So I can say no, I don't want activism. No, I don't want any kind of movement, LGBTQI movement, because my focus is not that. No. Then I don't want anything from America. I don't want anything from Europe. Now you see, I have relevant 6 and irrelevant 8, and it is saying enough knowledge I am having. You don't need to train more. You can keep on going, but I have prior knowledge. You can close me now. You see, 2000 abstracts are there. I only have gone through 6 relevant and 8 irrelevant. Now I can close. So 14 documents I have only checked and found 6 are relevant, 8 are irrelevant on the basis of my focus, my searching. Then I can click next, and there are different models. So sentence bot from Google, embedding idea. So this I am actually experiencing, and I don't recommend you because this will take much more time. So by default, TF-IDF model is there, term frequency oblique inverse document frequency. Classifier you can use NavBase, that is a very good classifier, and rest of the things you can take the default. So almost everything I have taken default. Now click next. So it is now giving training to the system. So this training, retraining, these are the new term, and you always wonder what is happening. This is, my dear friend, is training. I am giving some level data like we have during supervised learning. I told you group A data, group B data, and so on. So you can see AI is now ready to assist you. You can start reviewing again. So this is not that chance you lost your review chance. You can again check whether it's relevant or irrelevant. But as our time is limited, I can now click export the rank data, entire data set I need, file format I need TSP, CSV, and I can export. So now I am saving this AS review dataset CRM. So this data came here, AS review dataset. Now if I open with my LibreOffice Calc, here again you see here the same dataset, but you see the last column now. Last column, you remember we had EID. So this one. And now you see what knowledge I have given prior, those are actually re-ranked and came in the top. What I said irrelevant, that went down to the bottom. This the 8 lower ranking document. So it's actually re-ranked, and interestingly told me that this is the ranking result. So all of this one, what I ranked relevant and irrelevant, in between it actually ranked all of this paper on the basis of their relevancy. Now I can select that, let me select only top 50 to bring it for further review. So you just imagine you are having 5K record, 6K record, 10K record. So you can easily train with 10, 15 documents. More training is better, but beyond one point, it is not creating any fruitful thing. So I found that 15, 5 is optimal. Maximum you can go 15 each, minimum. 15 relevant, 15 irrelevant, depending on the size of the paper. So 10K paper we checked in this way. 15 is just optimal value for 10K. Up to 2K, 5, 6 is just optimal value. So it can rank, and according to that you can take 10, top 50, top 100, and so on. So this is A's review, and now we are almost at the end of our presentation, where I would like to show you some of the advanced level, that is the group C, that how we can utilize automated categorization and a system called RAG. So what is RAG? I am first taking a RAG. Now in this particular slide, you see here large language models, we always wonder that, okay, how this kind of human like text generation is possible almost flawlessly, no grammatical mistake, and in different tone, different style you can write. But don't forget that these are not knowledge generation system. You cannot ask a question to this system and can expect the right answer. These are not meant for that. These are not expert system, knowledge producing system. These are at the core of the core statistical tool, which can determine which word is statistically most significant and suitable for the next word, and how to complete a sentence. Nothing more than that. There are many things that I make my GPT model, BART model like Gemini, Claude, God completely in the wrong foot. For example, here you see I am using ChatGPT model is this one, and this question I raised on 19 September at 10 p.m. Is it true that there was a delay of 4 minutes in launching the Chandrayaan 3 project? I made a spelling mistake here. Anyway, Chandrayaan 3 project. If true, what were the reasons? Now you see, the trick here is the misleading the system. There was a delay, but delay was of 4 seconds, not 4 minutes. So one of the problem of this large language model is hallucination. It don't know how to say no, and another is the out of date, out of context information. If it has no information, no clue about it, then also try to answer. And that leads to hallucination. Now here you see the answer. Yes, it is true that it just took my lead, the wrong lead, the mislead. It is true that there was a delay of 4 minutes in launching Chandrayaan 3, and then it started producing a lot of good for nothing, reasons that there was everything, this thing, not the proper reason, because it does not know that there was a delay and what's the reason of this delay. So here, my dear friend, the reason, or if you want to use your large language model productively, be very, very careful. It cannot produce research level text for you. Very clear. Very clear and a complete period. No, argument of it. It fails every time you ask a question. You try to use it as expert system, because as I said, it's a statistical system. Its role is to predict the next suitable word after a word and complete the sentence. That was the purpose. That's why it is called large language model. Otherwise, they could say it's an expert system. We are using, or the byproduct of this one, and hallucination on our part is that we consider that as an expert system. It can write a very good school essay on integration, national integration, good habits, and so on, but don't expect that it will write for your research project. There are many misnomer, misinformation, confusion that people are using ChatGPT to write a book, write a paper. Not possible. Absolutely not possible. What it can do, you are write a paragraph, your input is your, it can rewrite that paragraph in different tone, in academic style. It can check the grammatical error and so on. Beyond that, it's impossible to use in any kind of productive thing. If someone is telling it, you are getting misinformation. And there is a problem that if you blindly believe in this tool, every chance you will be, your academic career may be at stake if you are not checking every data it is giving you. Because you see, the moment I mislead it, it gave me misinformation. Okay, and produce a lot of good for nothing reasons for it, because I said what were the reasons. So what's the alternative? I am not diminishing the value of large language. This is a beautiful invention made by human society, but handle with care. So what's that handle with care? A new technology came that is called RAG, Retrieval Augmented Generation. And it may be a solution to control and utilize the good part and bad part of large language model. We can utilize the good part, its capability to produce flawless text, its a huge vocabulary collection. Another thing is that we need to control the bad part, the hallucination and out of date, out of context information. So this is RAG, the concept first given by Facebook FAIR group, Facebook AI research group. And what is it? First I will collect a set of data. Suppose I am researching on nanotechnology, so I will collect around 50 60 number of good paper, out of it good papers that I have decided to include in my literature review. So that could be an application area. So that data source is applied, and that I can throw to a RAG pipeline. There are a lot of open source RAG pipeline I will be showing you. It will convert the document into chunk of text, and finally this chunk of text will be converted into vectors. So vectors is representation of the document according to XY coordinate. So that vector will be stored in a database we call vector database. Then next user may raise a query. Query will be converted into vector. So these two vectors will be matching. The query vector will be matched with the vector database, and it will retrieve the top 4 5 result. And that top 4 5 result will be throwing to large language model with a strict condition that you do not try to answer yourself. You read this 4 5 document and answer accordingly. If you don't know, if it is out of context, don't try to answer. Say clear no. So that is called prompt engineering. So we will train our LLM with the prompt engineering. A lot of open source LLM are available because ChatGPT, Gemini, after a certain point of time, they told you that your quota is finished for today, come goodbye, come on next day. And if you try to use that programmatically, it is very costly. So what we have deployed here, an open source LLM based, RAG, and thanks to Meta, thanks to Facebook, they have developed the Llama 3.1, which is open source large language model that we can download or implement. So here my experiment, let me show you my experiment here, how it provides. So I created one LangChain framework, then collected all of my related paper. Here it can be it could be your own paper, literature review paper. So I collected all the document on Chandrayaan 3, 200 English news articles, space release by ISRO, European Space Agency, NASA, etc. 100 Bengali newspaper clippings and 100 Hindi newspaper clippings to check the multilingual response from this one. And I'll show you my experiment. Then this document I converted into vectors. We are using one particular model called Infloat, available from Hugging Face. Hugging Face is another company that is supporting open source based, AI. So I collected their Infloat multilingual embedding tool called Infloat, International Float, and finally utilized DB to store the index. Then user will make a query. These two index will be matched. Top 4 5 result will be getting, and that top 4 5 result I will throw to LLM to utilize Olama or Llama. So Llama 3 I am using here in my system. So this is the thing that the moment I start, okay, let me show you this one in live. So let me close this age review, and everything I am running locally. So this is Python based. So I'm starting my server, and I can open it. So here you see this is the interface, And in the setting, I can select, these are a lot of open source large language model I'm using. So let us set Meta Llama 3.1 405 billion parameters. And temperature is actually increasing the temperature will lead to more creativity. When you are writing a poetry, creativity may be the highest. But I don't want any creativity. I want factual, to the point, correct answer. And search is enabled, that means retrieval augmented generation will be enabled. So I set this thing, and suppose I am asking the same question, say in Bengali. Let me copy the same question. Why should I? So I'm asking the same question in Bengali. I want to show you something important. Is it true that there was a delay of 4 minutes in launching the Chandrayaan 3 project? Here was a spelling mistake. So it is Bengali version is that এটা কি সত্য যে this one I can convert into Hindi also. So let me copy this one and ask this Bengali question here. And this is my prompt engineering. I ask that you are a helpful assistant, answer in the provided context and ignore context if it is empty. Query language can be in English, Bengali or Hindi. Always provide the answer in the same language as the query. So the moment I ask it, so it will first try to retrieve the relevant paper. Initially, it may take a few seconds. So all these relevant paper it retrieve. Now this particular document, it will be, I will explain everything. Let us complete it. So what happened actually? What magic happened? So you see, I just tried to mislead like ChatGPT. That is it true in Bengali that there was a 4 minute delay? Then what's the reason? So it collected the top 4 5 records, Bengali newspaper clippings, tried to utilize the meta llama for generating the answer. So that's why it is called retrieval augmented generation. I'm utilizing my this one that you use this particular document to answer me, and it is clearly saying no, it is not true that there was a delay of 4 minutes. 4 seconds. It was the delay was for 4 seconds. And you see, in case of ChatGPT and Gemini, you won't get any kind of references. It gave me a reference from where it is got collected, and this is URL. I can open the link to check whether it is correct or not. So this is the uh, Bengali newspaper from Shunu. That was actually the source. Okay, so in this way, you see here the same question I can ask for in. Let me see. And suppose I am now asking this in Hindi. Can it do it? Because in Hindi language there is no such this thing, no such newspaper clipping. So let me check. So this is the Hindi version of the same question. I am now giving Hindi, and setting is still Llama 3 and asking it. So it is now retrieving, you see now it is lightning speed and the Hindi newspaper clipping, and it can answer that मुझे इसके बारे में कुछ पता नहीं. So there was no training in Hindi language, so it can say no. And if I ask the same question like in Bengali, what I asked, so what is the utility? And you see these two sets of document retrieval is different. So here the language is changing, but still it is telling me the truth that chart it was delayed by 4 seconds, not 4 minutes, and giving me the references which I can hyperlink and I can go and check. And if I ask the same question in English, let us see what happens. So now it is retrieving different set. And now you see the important thing. So it is saying that no, the question is wrong. It was not 4 minutes, it was 4 seconds. But I got these references from Bengali newspaper. Uh, this one. So the possibility what I am trying presently here, I am not giving it training in English. I given training in Bengali for a certain facts, but it can translate Bengali into Hindi to gather the related vector. Now the research is due for how to make it inter-Indian language compatible. Now, Indian language and English compatibility is there. It can fetch knowledge in the regional language to answer in English, but not the intra-language like Bengali to Hindi or Hindi to Bengali. As you have seen here in Hindi, it is saying that I don't know. So that is the thing, and what is the how we can apply this RAG system. All our bits and pieces are available in open source. I can collect a set of documents in my for my research, 120 document. I can feed it, and I can ask many different questions. I can tell it to make a summary of these 4 5 papers with proper referencing like APA based referencing, MLA based referencing, and so on. So future is quite bright in case of scholarly communication. We can have our own, large language model system running in laptop like this, and a very sophisticated one. If we know little bit of Python and you know how to connect these bits and pieces, because most of these things are free. I am using Llama 3.1 without paying a single paisa. But if I want to use that GPT or Chat GPT or Gemini programmatically, I need to pay hugely, around around almost $800 per month. So that's all from my side. Thank you very much for your patience hearing and lot of interactivity. If you have any question, please don't hesitate to ask. Any question?
Not from my side, sir. Thank you. Nicely explained, sir.
Okay then. Let's call it a day. Yeah.
Yeah, I
So
was just I was just thinking, when is our next session? Because we are not informed. So are you aware?
yeah. So at 2:30 we will be starting our very slim valedictory session around 15 20 minutes at 2:30. So the
Okay.
coordinator will be there, director CRM Professor Anirban Mukhopadhyay will be there, and I myself will be there. So please join again after your lunch at 2:30. We'll be closing with a very slim valedictory session. Okay.
Thank you.
Thank you, sir.
Sir, just
Thank
one question. You have
Yes, please.
shown right now WAG GPT, right?
That is basically the rack file I am utilizing.
Okay.
I am using here LangChain. It's a rack framework, and that large language model from Llama.
Okay. So it's kind of a open source and it's available in GitHub as I can see right now. So
Yes.
to utilize that, we have to do the setup at our end, right?
Yes, and you need to have this local large language model. Either you can use Olama you need to set, or you
Okay.
can utilize any API based tool. Like I am using here an API based Llama 3.
Okay. So what you have shown just now, the API is free, right? Or are there any
It's
charges?
everything is free. Whatever
Okay.
today I have demonstrated, everything is free.
Okay. Thank you, sir. Thank you.
Fine. Okay then. Bye.